Now in 2015, there were 3 long questions. So 3-year Section B questions concerning calculus. So it's crucially important in paper 1 that you have an idea of your calculus. So in this one, you can read it through, your plane's flying horizontally, blah blah blah. Here it says this is the origin, and this is your curve, the track in which the plane's going. Now it's 0.15 kilometers, which is the same as 150 meters above it. And there's like your x and your y axis, your x going back -1, -2, -3, -4, -5. So it's 5 kilometers from touching down at the origin, which is 0, 0. Taking O as the origin, which is, as we say, 0, 0, approximately describes the path of the plane's descent, where here is your cubic function, part of your cubic function that describes the plane's descent between -5 and 0, which is just shown in your picture up here. Show that d is equal to 0. Now all you have to do here is, if a point is on a curve, the only thing you can do is sub it in. So at the point 0, 0, this is your x and your y, or your x and f of x. So fill it in to your equation up here. So 0 is equal to d. So anything with an x equal to 0 obviously cancels, so you're left with d is equal to 0. So that means d is read out of that there equation. Using the fact that p is the point -5 and 0.15, that's at -5 kilometers, or 5 kilometers away, from touching down. It's 150 meters, or 0.15 kilometers, just keeping the units the same. Show that c is equal to 0. So again, just sub it in, your x and your y. So your y is 0.15. C times -5. So tidy that up in your calculator. I'm just going to say that it's going to tidy out to give you c is equal to 0. Work through it yourself. And you should get 0.15 is equal to 0.15, or whatever, and c is equal to 0. Now, B part 1, find the value of f dash x, the derivative when x is equal to -4. So what's this going to tell you? It's going to give us the slope of the tangent line at 4. So it should give us a minus value, because it's going downhill, the slope of the tangent line at that particular point. So f dash x, your f of x now, is simply 0.0024x cubed plus 0.018x squared. Your c's and your d's are both 0, so they're gone. F dash x multiplied down by the power, so 0.0024 by 3, 0.0072, x reduce the power by 1, and here 0.018 by 2, 0.036x. So that's going to be our derivative, and now they've asked you to find the derivative at the point x equal to -4. Just solve in -4. You get -18 over 625, which is the same as -0.0288. Either or. Playing through it. The next half of that, use your answer to B part 1. So our B part 1, remember, gave us the slope at 4 kilometers from touching down. So the slope at 4 kilometers away was of the tangent line -0.0288. What's that? Use your answer above to find the angle at which the plane is descending when it's 4 kilometers, as we said, from touchdown. Give your answer to the nearest degree. And you'll see this right a few times. In order to work out the slope or the angle, the trig function that we use is the tan function. because tan, Sokatoa or Oliver had a handful of apples. It's the opposite over the adjacent. So basically, how far above the runway are and how far away. And we've worked out the slope of that tangent line to be minus 0.0288. So in order to find the angle from it, you just go tan inverse of that. And when you do the tan inverse 0.0288, you get 1.65 degrees. And here it just says to the nearest degree, so that's 2 degrees. That's a tricky wee one there. Next one, part C. Show that this point is the point of inflection. Obviously, if you're doing this in the exam, it'll take a lot longer. And then you'd have to think about them a lot more and spend more time on them. But we're just racing through it just so that you have solutions. Show that this is the point of inflection. And the point of inflection is where the slope changes from this, either spilling water to holding water, or from holding water to spilling water. All you need to know here, at a point of inflection, once you see point of inflection, the second derivative is equal to 0. Or f double dash x, if you like, is equal to 0. So we're just going to find the second derivative. So our first derivative, just in B part 1, we wrote down was 0.0072x squared plus 0.036x. Second derivative of that, multiply down to the power. Just power by 1. Now, what you do with this here, let it equal to 0. And we have our answer, hopefully you'll get these. 0.036. So what I did, let it equal to 0, got across the plus 0.036 and became a minus. Now to work out x, divide it. And when you divide that by that, you get your minus 2.5. Now that's only your x value. Remember, this point, like any point, is made up of an x and a y. And where else have we found a y? Back up in the original function. Your f of x is your y. So sub it all the way back into the start. Now keep in mind that your c and d are gone. So f of x is equal to 0.0024 minus 2.5 cubed plus 0.018 times minus 2.5 squared. Log that in your calculator and I'm sure you'll get 0.075. So therefore you've proven that the point of inflection by the second derivative being 0 is that. And the final section in this long question, so full of marks, is D. If xy is a point on the curve. So we've used this in A part 1, A part 2, and we're going to use it in D part 1 here as well. If it's a point on the curve, it satisfies the equation of the curve. Simply means solve it in. Verify that this here is also a point. So here, this is our x, this is our y. So sub back into that original function. You'll see it. Given that started the question, I'll write it down for you. 24 x cubed. And remember your cx and your d, they're both equal to 0. So we can ignore them. So this is our y. Our y in this question is minus y plus 0.15 is equal to 0.0024. Our x minus 5 cubed plus 0.018 x squared minus x minus 5 squared. Now this is going to take a lot of work. You have to be careful watching your signs. Don't be doing anything daft. Something cubed means write out that bracket 3 times. So minus y plus 0.15 is equal to 0.0024 minus x minus 5. I'll actually, no, minus x minus 5 minus x minus 5 plus 0.018 minus x minus 5 times x minus x minus 5. Or square the first, multiply the two together, double it, square the last. And when you do that, you get square root of x by x squared plus 5x plus 10x plus 25 0.018 times x squared plus 10x plus 25. Now work through that yourselves. Now, just watch your signs. Tidy that all up. And when you tidy that all up, you should end up with your original function y is equal to 0.0024x cubed plus 0.018 x squared. So you should end up with that, because it's also a point in the curve. Now, that will take you about 4 or 5 minutes to tidy that up and see how you get on, but at least you know what the answer is going to be. And in the last part of this, find the image of this point, so this point here, under symmetry in the point of inflection. Now your point of inflection, as I said, is if you're changing so here, point of inflection here, what did we say was minus 2.5 and 0.075. Here we have another point at minus x minus 5 minus y plus 0.15. So what we're going to do, we're going to go with same distance because of symmetry, same distance to the point of inflection as from it. So if it was 2 units here, if we're adding on 2 units, we'd add on 2 units here. If we're adding on 7 units, we'd add on 7 units here. Same distance to the point of inflection as from it. So compare your x values with your x, and then compare your y values with your y. So if we look at our x values, minus x minus 5, we're going to minus 2.5. So how did we do that? If you're looking at your letters first, we went from minus x to no x being mentioned. So how did they do that? Minus x to no x being mentioned, they've added on an x. They went from minus 5 to minus 2.5. How did they do that? They've added on 2.5. So if we've added on x plus 2.5 to the point of inflection, we're going to add on x plus 2.5 from the point of inflection. And we do that, we're back with our x, and minus 2.5 plus 2.5, 0. So our new x coordinate is simply just x. Now look at your y. Your y, you went from minus y plus 0.15 to 0.075. So we're going to go same distance to the point of inflection as from it. Same thing. We went from minus y to no y being mentioned, so we must add it on a y. And we went from 0.15 down to 0.075. Just find the difference between them. So we went down minus 0.075. So that was the distance to the point of inflection. We're going to go to the same distance from the point of inflection. So we're left with y and plus 0.75 minus 0.075. They disappear. So find the image of this point. The image is therefore xy.